In this session, we're going to look at absolute value problems involving equality. Absolute value represents the distance away from the origin. So the absolute value of -3 is asking us how far is -3 away from the origin. And -3 is 3 units away from the origin, so the absolute value of -3 is 3. Likewise, the absolute value of +3 is asking how far is +3 away from the origin. +3 is 3 units away from the origin, so the absolute value of +3 is 3 as well. In general, we have the absolute value of x is either x itself if x is greater than or equal to 0, and its opposite of x if x is less than 0. If we have an equation with absolute value, let's take a look at an equation like this. Absolute value of x is equal to 3. Well, in words, that is asking us what number or numbers have a distance of 3 units from the origin. And if we look at the number line, here's the number line, here's the origin on the number line, and if we start counting out 1, 2, 3 units to the right, we see that the number 3 is 3 units away from 0. So we know x is equal to 3. Now counting out on the left-hand side, -1, -2, -3, we find that the number -3 is also 3 units away from the 0. So we have two solutions to this absolute value problem. When we have the absolute value of x equal to 3, we have x is either 3 or x is -3. There are two solutions. So if we generalize this, we can say if you have the absolute value of some expression is equal to a number, and for now let's say that number is greater than 0, then z, that expression, is either the number itself or opposite that number. And that would be a strategy for solving equations involving absolute value. Let's take a look at an example. If we have the absolute value of x minus 3 is equal to 5, we can solve this problem both algebraically and geometrically as well, if we think about distance. If we find what the origin is, what makes x minus 3 equal to 0? That tells us x would equal 3. You add 3 to both sides, and this is the location of the origin. So if we make a number line, and this time starting at the number 3 is the origin, and counting out, just like we did before. Count out 5 units to the right. 1 unit, 2 units, 3 units, which is at 6 there, 3 units away. And 4 units is 7, and 5 units to the right. We would situate here at the number 8. The number 8 is 5 units to the right of the origin. And likewise, counting out to the left. 1, 2 units, 3 units, 4 units, 5 units to the left. We would have the number at -2. So the number -2 is 5 units to the left of the origin at number 3. So the solution to the problem of absolute value of x minus 3 equal to 5 tells us x is either 8 or x is -2. You can check by substituting 8 into x. 8 minus 3 is 5. What's the absolute value of 5? 5. Plugging in -2 now. -2 minus 3 is -5. And what's the absolute value of -5? 5 as well. Now if we use our results up here and use it algebraically, the only way x minus 3 is going to equal 5 itself is if x minus 3 is indeed that value of 5. And what's the absolute value of 5? 5. So adding 3 to both sides, we get x is equal to 8. The other possibility is for x minus 3 to be -5, because what's the absolute value of -5? 5 as well. So you have x minus 3 equal to -5, and when you solve that equation, add 3 to both sides, and you end up with x is -2. So those are the two solutions to the equation.